Thank you all for coming to the second week of ExeWebDev. As you remember from last week, we studied the front end. This week, we're looking into the server, the backend side. We'll also be looking a little bit more at an holistic thing, kind of also how to host your server, how to make it up, how to link it to a domain, and how to put it up. So I got a little bit of feedback from last week. That's a bit fast. I understand that's why my first thing was the meme was doing in 3 hours. You are welcome, obviously, to follow me, but we're going to install several components. If you don't want to just sit back, especially people online, just relax, and you can just watch the recording and do it on your own. As last week, I'm going to share the code at the end, so just go into your pace. Unfortunately, we'll have to go over several things for you to be able to have knowledge in an hour and a half. But as I said, if I'm going a bit too fast for you to follow, you can maybe, for the people in person, can just interrupt me, ask a question. There's no problem for that, but you can just stop and follow me later. So first of all, a bit of homeworks. There was downloading Node.js on your computer. So you can just go into nodejs.org. You can do it now, especially for the people online. It's going to take a bit of time to download. It's not that big. But basically, we're going to host our server on Node.js. But that's how it's going to work. So it's downloading on your own computer. You just select continue, and that's it. Optional, but heavily recommended, creating a GitHub account, which is where we're going to host our code. We're going to put our code on GitHub. I'm going to explain that. For those that did Excode, we already covered some of those topics already, but I'm going to go over a bit more precise, like practical way. So first of all, I'd like to cover for the first 20 minutes a couple concepts that I think are important to know to kind of get into the code, but then we'll obviously go into the code, create a note-taking application. And so the first concept we have to see, which is going to be quite quick, is the concept as a command line interface. There's a really simple way to explain that. When you have Windows and Apple, but also Linux are the three main, they are interfaces which we call GUI, graphical user interface. So the idea is you interact with it through a graphical. So if I go here on my computer and I go into the folders, well, that's a graphical interface. That's how I interact with my computer. And that's why now it's so much easier to interact with a computer than it was in the 80s. You don't have to write everything in a command line. You know, when every time in the movie or you see like, or even before, you see that kind of approach of people just writing lines to create folders. Now you can just go here and go right-click and create a folder and create a new folder or remove a folder, rename a folder. So that's how you can interact with the files on your computer. That's a graphical user interface. A CLI is a command line interface. So the idea of this is you write commands that makes the same exact thing happen on your computer. There's not a lot of commands we're going to cover here. Many of those concepts, there could be entire books about those. But basically, we're going to only probably 3. That's what we're going to use. So I got a list here. We're going to probably only use the first 2, which is ls and cd. So ls is about seeing what's inside of a folder. You type ls, and you can see what's inside of a folder. cd is to enter a folder. And you can move around folders. The only reason we need to know that is because to start our server, we need to move into our folder and then say node start. That's it. There's not going to be a lot more. Obviously, you can get really complex. You can create folders, which is make dir, call it directory, but it's a folder. You can create files with touch. You can remove those. You can do more stuff. But the really basic stuff we're going to do today is simply looking all the things that are inside of a folder, moving into the right folder, and then saying node start. That's why you have to install node to be able to run that line, which is going to basically run our server on our computer. The second concept is version control. Version control is another concept we need to see before looking at the backend, and it's about how code is hosted, especially when you work in real life with a team. So basically, the whole idea is now, when you create a folder on your computer, it's local. So when I go here, I am the only one able to access it. But here, there's actually one thing, which is the OneDrive, whereas the folders are not stored on the computer, they're stored on the drive. And so that's why when you go into another computer, you can have access to the same folder. GitHub is exactly the same, and it's version control. The only difference is that it's not for folders, it's for code folders. So basically, the way it works is you create a repository, which is a folder on the cloud, and then you can invite several developers, and the developers, they can do something which is called push, And so which is literally pushing their code from their computer locally to GitHub. The reason I'm telling you that, there's two. The first one is because that's how actually you will code in real life. As soon as you have more than one person working on a project, you'd probably have GitHub. Imagine if you need to have a USD every time you want to pass the code. Like, take the USD, you can only code. No, you have, it can be really complex, because obviously the way it works is allow several developers to work in real time. So there's whole like technology behind, which is Git, which is the branches system, which is like a tree. But we're not going to into that. At the moment, the only thing we need to know about that is probably tree command, which is git init, start a Git repository. But with GitHub, there's a GUI. You don't have to interact with the CLI. So you can literally just go and click create a repository on the platform, on GitHub. So you don't have to do everything by command line. So you create a repository on GitHub when you have an account, and then you can connect your code to that repository by, say, git init, you initialize it, then git commit, which is let's put all the code into the cloud, and git push, which is pushing it into the main thing, basically, and that's it. So two things we need to know beforehand is a CLI, which is a way to interact with our computer by text. And on the CLI, you can use several commands. One is to move around folders. One is node to start our server. And the final one is git, which is about pushing our code on the cloud. And then I can send you all the link. Actually, what I may do is to create a public repository for today and just share you the link of that public repository. So then you can do git clone, and you can all clone the code of the repository on your own computer. It's much easier than actually giving you an entire folder of 10 gigabytes and sending that to everyone, obviously. You can select, so either public or private. Or you can, if it's private, you can invite people. Then there's a whole like organization with granularity. Obviously, like if you're a really big organization, you have, the CEO can see all the repository. You have developer that can work on some repository. The main idea behind GitHub is open source mainly. So the idea is people put the code open source, and other people can add comments or add their own, they can solve bugs. So actually it's the entire community that's working on some code. That's like the ideal behind. Obviously, you can also use for smaller project or like closed project. But the optimistic side is open source. So you just put your code up there, everyone contributes to it, and it's like a community project. A lot of big projects are actually open source. We can maybe look at some after if you want. So we'll look at a demo later on when we go into the proper thing. We're going to create an actual Git repository and everything. And then we can start talking about the backend. So this was two introductory contexts. And in the backend, I'm going to start by introducing APIs. And I need a volunteer here, someone from the audience that comes here and talk with me. Can I have someone, please? Anyone, you select. OK, come here. Come here. You have to come here. What's your name?
Ollie.
Ollie, OK, thank you for being here. This is not going to do too much. We're just going to talk, and you're going to be the server, and I'm going to be the client. So what we're going to do is going to simulate an application and how it works. This is an API. The whole idea of an API is a way for computers to get information from the web or from data sources. That's kind of a generalization, but that's the idea. From APIs, we're going to explain servers. But API is a bit simpler. That's why we're starting with it. So let's say I'm a human normally. I'm not still an application. And I want to see the weather in any city. Let's say Exeter tomorrow. What will I do? Someone wants to explain, what should I do? I'll just open my computer, and then I go on Google, and then let's do it together. Like, weather Exeter tomorrow. And then maybe I'll ask you you are on a website, and you tell me the weather.
OK, it's pretty good today, actually.
OK, that's great. That's great. So that's a human, and you're a website with like your own server and your own client. Sorry, your own server, and then you send it to me, which are the client. But I'm a human. Now, let's say that I'm no longer a human, but I'm an application. So I am a server, and I want to know the weather. So I cannot go on Google and Google weather in Exeter tomorrow. I mean, yeah, it's raining tomorrow, unfortunately. So sorry. But so basically, what I have to do is we have to have a protocol or a way for me to communicate with you. So what are you going to do? You're going to put up an endpoint, which is a URL that is made for we can call them bots, but actually servers that make requests. And then when I want to know the weather, I'm going to make a call to that URL, which is exactly the same as clicking it and loading the page. Still an exchange of data, but rather than actually going to Google and searching for that, the developer writes that URL in, and then the app goes to say, oh, from this URL, I want this thing. And actually, it works. There's a bit more complex. But the main idea is I ask you something. So let's do the main thing. First, I'm a developer, and I'm going to create an account on your website, which is about knowing the weather. So I create an account manually, and you give me an API key. So give me that API key.
Okay.
Thank you.
Yeah.
So this is a key that is associated with my account. So this way, he knows that whenever I use that key, it's my account. I'll probably also give you some billing so that you can associate that key with to make me pay, basically. That's how it works with ChatGPT API. Now, whenever I want to know the weather, or one user wants to know the weather from me, what I'll do is I'll take the URL you gave me, put the key into my request, and then also put some specifics, like I want to know the weather in Exeter tomorrow. So I'll take that packet, which is on that URL, so I know I have to send it to you, the key, and then the weather in Exeter tomorrow. I'll give that to you. What you do?
Take that.
Yeah, and then what you do? First of all, you see the key, check that it matches, right, and bill me. You add like 10p to my account. Probably now it's free with the weather, but for advanced application. And then you give back to me the weather in Exeter. And that's how we have a communication server to server. Do we get it? Yeah? So what I give is URL, and then a key to identify myself, and then some information. It's like a question. Give me the weather in Exeter, but I'll do it as parameters, like location, Exeter, time, and time. That's how it works. So that's our communication server to server, an API. And I can be anything. I'll show you later on my screen if you want something a bit fun. I've downloaded an LM model locally on my computer. So now I have 2 servers on my computer, and I can make them call themselves. So it's like, rather, I don't have to pay to ChatGPT API. I can just have it for free because it's running on my computer. So you can also do that. But it's 2 servers that talk between themselves. I'll show that later on. Then now let's make one step forward, and I'll just keep you a little bit more. If we got into API, RESTful API is just a way of calling APIs, which is like the right way of doing it. But there's no need to go into details. I'd invite you. I'll put as a resource to look into, like, there's obviously rules into how you should write those APIs, which is not the topic of today. We're not going to write an API. But there are rules, and it's called RESTful in a certain sense. So if you want to look into that, it's going to be in the resources. And now we go into our server to server. So we take the thing we just learned about API, but now it's a bit different. Is I am the client, and you are the server. So we are part of the same website. We're no longer 2 different people that communicate. Part of the same website, created by the same firm, but we host it differently. Maybe I'm hosted somewhere, and you're hosted somewhere else. So we still communicate in the same way. I called you as an API. You're still kind of an API for me, but you only for myself. So let's take the example of a note application, which I think is quite good. So you are, we probably need another person, but let's say there is here an imaginary person that acts as a database, okay? So that's where you will store the data. So first, I am the client. A user visits me and kind of open myself and looks a note application and create a note. So what I do is I say, OK, you want to create a note. I'll take the content and the title of that note, pass it to you. You take it. Maybe you do some check. It's like you sanitize it because let's say the user is trying to hack the thing. So you check is not trying to hack you, so you have some. And then you pass it to the database. The database remembers it. Everything's all right? Did it work? Yeah? Yes, so send it back to me now. You send success. So I'll take, oh, success. And so I show on the screen of the user, success. You created a note. And that's the first operation, the C of what we call CRUD. Create, read, update, delete. Now the user reloads the page. What I'm going to do, I want to show him that note. It's stored in database. I want to show it. So we do the same thing. You reload the page, but we want to show. So we have to read the notes in the database. So I'll tell you, usually we'll have, the user will also have an ID that we know it's that user. So I'll pass you the ID of that user, and I'll say, read all the notes by this user. Give that to you. What are you going to do?
Go to the database and try and retrieve the notes that are under that.
That's great. That's exactly that, yeah. You retrieve all the notes by the user, and then you pass that to me, probably as like JSON or anything, any type of data like text, just as text, simplify it. I'll take it as text, and then I'll show it in HTML, in my HTML. You get it? And then I can update. Let's say I want to update a note. Maybe I probably have a note ID. So I'll say, there's this user ID that wants to update this node ID. Yeah. Take that, pass to the database, update the content, send me the confirmation back to me. And then on the screen, I can show there's a different content on the node. And then finally, delete is the same. I just delete a node and you remove it from your database. Yeah. Thank you for your help.
Yeah, no problem.
So that's our system. Is it clear? All good? Let's take a bit of water. So let's say the web is all about communication. It's not just not human, but computers, but it's about exchanging information in a really smart way. About database, I don't want to go too much into the details here. Myself, absolutely not an expert, but basically the main concept here is that there are two main types of databases. One is SQL, we talked about that, remember? One is non-SQL. Really simply, SQL is a table. Non-SQL is everything that's not a table. That's basically it. When you create a database, you make some choices. Do I need SQL? There's plenty of providers of SQL. There's plenty of providers of non-SQL. I had good luck with AWS because it's free at the beginning, but it's quite hard to get into. There's simpler one like Firebase. There's actually plenty. So it's up to you to what you discover, what you found out. When you want to create an application, you do some research. Does it need to be really structured? Do I need to be really table format? Probably go with SQL. Does it need to be fluid? Is there like a lot of updates? Non-SQL. We're not going to create a database. To create a database, usually how it works is you have to create an account into a platform, get an ID, a code, link that to your own code, and then have them communicate. So they can, like as we just saw, they just talk with the database and you create. It's exactly the same. We're not going to do this bit. We're just going to do this bit today. It's not about database, it's about server. But I just want you to know that actually in real life, you probably have a database talking with him. And actually the server, you could be talking with hundreds of people. You could be talking with the database. You could be talking with ChatGPT. You could be talking with the weather API. Maybe, I don't know, when I was coding an app to help people write, my server was talking with a dictionary API. And so what was happening is while the user was writing, it was suggesting synonyms because my front end was saying, oh, this is the word. The back end is saying, oh, goes to the dictionary, says, I want all the synonyms of that word, up the chain till the front end, which shows them on the screen, and the user can select those. That's basically it. It's all about communication. And then, yeah, the concept of CRUD is quite important. And this is what we're going to do today, create a Node application with Node and Express. Some really quick concepts here, which we don't really need to touch upon. We are really quickly during the code. Routing and caching, basically the idea is what we saw last week was simply, I want to get Apple, and you get that thing. Usually, you get several URLs. You get, I don't know, /home, /about, and you get hundreds more. So routing is just deciding what should each URL be and what page should it shows. And then you can also have something called a sitemap, which is linking every URL to every page. And then usually you submit that to Google, which we may be going to try to do it today just to show you. And then Google shows your website magic on Google, and it's free. So that's quite good. Caching is another concept we're going to see, but it's about how these pages load efficiently. So this is a sitemap, and basically when you do a sitemap, you also see how can I structure my files. Because last week we had 3 files, it wasn't really hard. We have home, home, home. When you have 100 pages, there's a way you structure your files. What I really like doing, there's plenty of ways you can, is I have a folder for my CSS, a folder for my JavaScript files, and a folder for my HTML files. And I just do like that. And then I have a folder in React is kind of much better. So we're not going to go, there's no need to go into deep into all these concepts because next week, well, the reason a lot of people use React is because React does this automatically. React helps you with the routing, React does the caching, it does it by itself. Hosting is important because when we're talking before about our system is probably going to be hosted somewhere. So then we associate that hosting with a URL. We have an IP address when you host it. We're going to do it today. Then you associate with a URL, with a domain name server, and then people can go into your website. So get a domain and get it linked. Security, it's an SSL certificate. Remember last week we talked about the S in HTTPS. That was quite important. If you have only HTTP, a lot of websites are going to be blocked, so you need to get that S. With some hosting, you just don't have to even to do it. It does it automatically. With Firebase, which is what we're going to use, you don't have to do anything. It just, when you connect your domain, you just say getting your certificate and it gets it for you. Just, you always have to look that it is. And then indexing SEO analytics, what I just talked. Once you have a domain, you can send it to Google mainly, also Bing, and they're gonna parse it, so they have a bot that checks that it exists, and then they put it on Google. And then you can also connect analytics. So look into, for instance, how is it ranking? And you have, like, for the keyword, I don't know, say I'm doing a pastry in Exeter. If someone search Cornish pastry, I'm going to be first, I'm going to get 100, because it may make the difference between life and death for a business. Because if you're first, maybe 50% of people that search it go and buy through your business. If you're 10th or even second, it may mean that you're actually losing 20, 50% of your business. Now with AI, it's a bit changing, I know, but it's still extremely important. So that's all.